welcome to the Hopsteiner Webinar Speaker Series, Hoppy Topics. My name is Darren, and I'm part of the success team here at Hopsteiner. The Hopsteiner Webinar Speaker Series, Hoppy Topics, is a free online educational seminar with presentations from our lead researchers and hop scientists. Each presentation was created to address hop-related challenges brewers face on a daily basis, and we hope their latest discoveries help you in your quest to brew better beer. Sadly, this marks our final episode in our series of Hoppy Topics. A link to all past webinar recordings are available on our website under the online customer portal page. We have had some great presentations with some awesome speakers, but none better than the guests and speakers with us here today. Joining us today is our lead variety development and bioinformatics scientist, Nikolai Petra, along with our director of sales and marketing at Hopsteiner, Doug Wilson. Doug began his career as a craft brewer in the Chicago area before jumping into the malt industry prior to joining Hopsteiner in 2015. Doug earned his BA at the University of Notre Dame and completed coursework for the International Diploma in Brewing Technology at Siebel in Chicago and Dominz in Munich. Also here with us today is Tom Nielsen from Sierra Nevada. Tom began his professional brewing career at Sierra Nevada Brewing Company in 2004 after obtaining his bachelor's in food science and technology from Rutgers University in New Jersey. Tom heads the research and development department at Sierra Nevada, managing all aspects of the brewing quality, method, and process development for brewing innovation. Last but not least, we have our questions moderator, Mike Sutton, Vice President of Craft Sales, who will be helping facilitate questions for our panelists at the end of the webinar. Tom, Doug, Mike, Nikolai, thanks for joining us.
Thanks, Darren.
Thanks, Darren.
Yep.
So basically, the Hopsteiner breeding program over the years has produced a number of pretty exciting varieties. And you can see here by the commercial variety timeline that the first of the long series was back in 2006 with the release of Apollo, Bravo, Super Galena, and then followed a few years later with Delta in 2011, Calypso 2012, Lemon Drop 2014, Eureka 2015, Sultana 2016. Then more recently, Lotus in 2019. And then we also released a Trident blend. And then our newest two releases for this year, we recently announced Contessa and then also Altus. In the background, on the right side, you can see we have a number of experimental varieties that are currently available either in the 5-acre plot or in our multi-hill nursery that are the new upcoming, what we call new generation exciting varieties. So in order to get to this level, we'll go ahead and turn it over to Nikolai to talk about what it takes to be able to produce these new exciting varieties.
Hey, Doug. Thanks, Mike.
Hey.
So I'm going to do a quick overview of molecular breeding, which we talked about in the last webinar, but just a quick overview for the people who may have missed it or maybe saw it last time just to brush up on. But we use molecular breeding in three main ways. The first way is we can assess female traits in male plants. Male plants do not have cones. So in this example here, you can see that we've phenotyped this female cone for the trait cone size, and we said, small, and we found a marker for it. This is obviously an example. And a large phenotype, large cone size phenotype, we have a marker that looks slightly different. So what we can actually do is then look in the males for this genetic marker. And in this case, we could see that the male would have the trait for large cone size in its progeny. So we can actually select males for cone size even though they don't have cones. So that's a pretty powerful trait that tool that we can use with molecular markers. Secondly, we can see what we call invisible traits. So let's say the female plant is resistant to powdery mildew and the male plant is resistant to powdery mildew. And we do a study and we see that it's for actually different reasons. This is the powdery mom, powdery dad marker. And when we look at the kids, all the kids are resistant, some because of mom, some because of dad. And with molecular markers, we can actually see some because of both. This is what we call stacked powdery mildew resistance. And stacked powdery mildew resistance is important for a few reasons, but one, it's more durable. So sometimes powdery mildew resistances can be broken. The disease can change slightly and actually overcome the hurdles of a one resistance. But if you put two resistances in the plant, it makes it much more durable, and the resistance has more longevity. And so this is an important trait that we're able to see with this. And the final thing that really helps the breeding program using molecular markers is we're able to speed up the breeding process. So the typical breeding process, which I went over in detail in the last webinar, can take up to 10 years before you get to a semi-commercial variety where you're actually doing pickability, extractability, commercial scale brew trials. But with molecular markers, we can have a lot of confidence in plants early on in their life. We can even, we can make a 6-year leap, which is kind of a shooter's shoot mentality, and a 4-year leap, where we can be pretty confident and we can skip a single hill nursery, go straight to a multi-hill nursery for further agronomic assessment. And this actually makes it the breeding program much more able to react to markets, even though it's still a very long time. It is pretty exciting to move things along quicker and get new varieties into the hands of brewers faster. So I'm going to talk a little bit about Hopsteiner and Aroma, and not necessarily varieties, but also sort of like lineages or genetics that we are using or goals that we're achieving. There are more than this, but these are the ones that have made the most progress in the recent years. So I kind of named this oil maker. What it actually is a kind of a nugget lineage, or nuggetoid, I guess Paul Matthews says a lot, but has high total oil, some of them reaching around 5% total oil, high in bitter acids. Sultana is also carrying some of this lineage, as it's a very high oil hop. One of the goals we have is looking for new nobles, ones with the 1-to-1 alpha beta ratio, light, spicy aromas. It's actually found in several different lineages, but it's a target that we always assess for. It'd be like Saz or Holletower Middlefruit-like traits. And Contessa is a hop that actually has these traits, and is an exciting hop that's coming out, or just this year, I think was the first slide said. So another thing we're doing is a hybrid neomex, which is where we actually integress Neomexicanus into our germplasm, using markers for resistance, or having an idea of different traits to improve the Neomexicanus while bringing its interesting traits along with the integration. So we're finding unique aromas: coconut, orange, cream, cocoa, like chocolate. They have medium alphas, so some of them actually can be used as dual purpose. Lotus has come from crosses like this, and 06300 is a really interesting plant that didn't quite make the commercial bar, but is being used also to advance these lines and make new hops in the future. Juicy Juice is kind of vague, but on purpose. But there's a new 40 Hill that's from this aroma line. There's a lot of juicy fruit type of aromas. It's pretty exciting stuff, and they all are stacked with powdery mildew resistance, and are quite good hops. And so that's an exciting line. The traditional American is sort of like the traditional American aromas with a twist, like Cascade-like, with improved agronomics. Lemon Drop came from this, and 09326 is an example of a traditional American type hop coming out of the system. And there is, again, a new one in 40 Hill this year, which is exciting. I think it has a pretty big aroma, but it still is from this traditional American type lineage. And then we have the novel chemotypes. Novel chemotype is sort of means new chemical profile. So we're using hop genetics that have chemical profile diversity outside of what you might normally think the hop chemical diversity might look like. And markers are allowing us to make calculated crosses confidently that, we might not think of knowing what you know about the hop germplasm, and we can, kind of reach outside or make some, genetic distance crosses, or, but confidently, which is exciting, and it's resulting in some really interesting and exciting aromas with varying levels of oil diversity and terpene diversity, which we'll talk a little bit more about later in this. So one thing I want to talk about, and this is also the importance of lupulin. In this example here, we have an older variety, I'm not going to name names, and a newer Hopsteiner breeding line. And if you zoom in, let's see if I can zoom in. I got to take off my little pointer thing, sorry. Laser pen won't let me click. So if you zoom in on this older variety, you can see that there's some lupulin here, definitely. And if we zoom in on the Hopsteiner variety, you can see that we're increasing the gland density in these varieties and getting quite a bit more lupulin in here. And why this is important is lupulin is actually a modified trichome. It's found mainly in the mature female hop cone on the bracteal of the plant. So these are bracteals right here. They're the little leaves. There's bracts and bracteals on this, but mainly on the bracteal. And trichome is actually just a fancy word for plant hair. If we zoom in a little bit, you can see a little bit more up close. They look kind of like little balls. Zoom in a little bit closer. And so these lupulin, or hairs, are small structures that accumulate the secondary metabolites and the oils during the ripening of the hop cone. They actually accumulate in the subcuticular area, which sort of means like accumulates in a cup that has a, I don't know, cuticle on top of it, and they fill up with these interesting compounds as the hop matures. The structure ends up looking a little bit like a water tower. This is even a close-up of this, a very recent paper by some great scientists. But you can see that these hop trichomes are actually slightly immature in this picture, but are accumulating these compounds here, and they kind of grow out. So you can see where I got that water tower analogy from. So these are immature peltate glandular trichomes. And so let's see. The reason I'm bringing all this up is because one way to think about this is, cannabis also has modified trichomes that secrete and accumulate interesting compounds. So if you imagine in 1957, when Cascade was bred, somebody could, smoke a joint of cannabis on the beach and feel kind of groovy. But if maybe you did that same thing with that same amount now, you might have to go to the hospital for a panic attack. I say all this to frame the thought process that your pilot recipes, let's say, call for 3 pounds of Centennial. And so you say, okay, well, a hop's a hop, and you add 3 pounds of 07270, not really realizing that because of the lupulin content diversity, it might be like adding, 9 pounds of Centennial in reference to the lupulin glands. And so with some of these new varieties, I guess what I'm trying to say is smaller additions can actually make for a better experience. Some of these big lupulin count plants added with not such a heavy hand, you can actually get some subtleties without, overwhelming the sensory experience. So I'm going to talk a little bit now about genetic chemical content diversity. So using markers, we're able to breed hops with disease resistance, drought tolerance, higher yield, etc. But also we're able to start breeding chemical content diversity, which is allowing us to make some sustainable hops that have really exciting aroma profiles. So this slide here actually shows on the left and a handful of commercial varieties. And on the right, we have a smattering of Hopsteiner experimental varieties. And I can't guarantee that all of these are going to make it to market, but they're all at different points in the pipeline, but they are very exciting. One of the things you can see off the bat is if you look, it's kind of hard to see, I guess, because the yellow and yellow, but the darker yellow is actually that other oil. And what I consider other oil is oil that is not one of these big 8 that you typically can see in a GC data output. So everyone should be pretty familiar with these big 8, but the other is actually starting to accumulate pretty high in some of these hops, and that's really exciting to me because I do not know what they are going to brew like, what they are going to taste like. They smell great, but it is exciting. Some of the other things you can see is you can see high linalool in some of these, high limonene in others. You know, you can also see decreasing myrcene, which isn't decreasing linearly or anything like that. It's just the way it's sorted right now, but high farnesene in this one. So these oil profile diversity that we're achieving, to me, is very exciting, and I'm really excited to see what you guys can do with these hops and what they're going to end up being like.
Nikolai, Tom here real quick, Tom Nielsen. The low myrcene content in some of these experimentals, has it been verified via the genetics, or is this a function of harvest time for these hops? So, would these experimentals with low myrcene that you're seeing still exhibit low myrcene if kept on the vine for 2 more weeks per se?
So I've actually had this thought as well, and had other people ask, were these missed peaks, or is it an artifact of harvest time? But we have verified not all, but several of these low myrcene, especially the extremely low myrcenes. I was talking to a scientist from Sierra Nevada one time, and he pointed out to me I could have just missed a peak. So we went back and actually verified that peak. And then I think because of this general trend of not all of these, but several of these having low myrcene and being picked at what we considered a good pick time, just the the population size of low myrcene, even of the ones we haven't been able to go back and verify. Let's say they're a baby last year and I haven't visited them again and they're multi-hill this year. The trend leads me to believe that we have pretty good evidence that this is real, not an artifact of, but it was something that I went back and verified because, yeah, it's an oddity. So it's exciting.
And Nick, these varieties are meeting our agronomic thresholds for yield as well, correct? They're not just, outliers.
So there are, like I said, they are at different places in the pipeline. So some of these, might be in single hill. I do know for a fact that, there are a few of them over here that are in 40, which I'll show you at the end. We'll talk a little bit about those, but yeah, I can say that they've all been advanced at least once. But like I said at the beginning, I can't guarantee that they're all going to meet our yield standards once they get, a little further through the program, which is just the nature of operating.
Yeah. And I think this is really exciting. It kind of turns the total oil analysis on its head, right? Because, a lot of varieties out there these days, they're 65, 70% myrcene, which, if you're using on the hot side, that myrcene is going to volatilize off. And so when you look at some of these varieties that, like those first few charts, there's practically no myrcene. So, the total oil analysis for those might be lower, but when you think about what actually is making it into your beer, it's actually substantially higher. And it makes for some exciting brewing trials, and, looking forward to getting these in the hands of you, the brewers, to let us know how they taste and smell.
Exactly. It's kind of like I think at some point in time it was, hey, this is a good hop, you should use it, figure out how to use it. And now we have, a plethora of good hops, and I'm kind of like, which one do you like? You guys should help me, advance, because at some point, I've brewed before, but I'm nowhere near a brewer. So I also wanted to mention that we are using these technologies, not just on the aroma side, but also for alpha. So, some of the exciting alphas that we have coming out this year. 15619, a 5 acre will be mature this year. It's a beast of a hop. I kept saying it was my 2020 for 2020. And, we still got to collect some data on it, but it's an exciting hop. 715, you can see because of his first two numbers are the, not the cross year, but the first advancement year. And so this one, obviously, we are taking a shot on. We have some large families in 529. They're stacked powdery mildew resistant. They have downy mildew resistance and high alpha. They're a very exciting family on the alpha side. 17716 is actually one that I'm really hoping for this year that it shows up and shows out. It had 19% alpha in early August. And this is an important trait for hop breeders as well. If we're able to, get alpha done early on in the, and extend the harvest window into August, we can spend more resources, more kiln space, more picking time, and actually hit, aroma pick windows with much more force, and, try to get, or like, if we need to wait a day on something because we have a lot of the alpha done already, maybe we can wait a day and afford to do that, where, during harvest, everything is kind of chaos. And so getting earlier alpha would really lend some flexibility to a normally very chaotic time in September. If you guys have been out here, you know that September is a madhouse in Yakima. So extending that window would be really exciting. So this is something that we're hoping to achieve. And also you can see in this variety here, we're getting very high COH, which is important in downstream processing. And so it might not be the bittering hop you want, or maybe it would be, it's up to you, but the COH is important in downstream processing, which is also a big part of what Hopsteiner does. And so it is another breeding target, and we're also achieving an uptick in COH. One of the things looking into the future of alpha a little bit, you can see this graph here is talking about marijuana potency. There's also graphs with corn yield that look like this, but essentially you kind of for a while you feel like this is the highest you can get, and then as you breed for traits like gland densities, or you start to find and exploit secondary metabolic pathways, you're able to really start increasing these. You can see this is just 2010, and actually 2020, I think the high, it's the high in THC is now nearly 30%. So this has continued to climb for 10 years. And so we're trying to, I guess, you could call it an alpha wall, but we're attempting to, explore how we can, we have all these great varieties here, but you can see they're all sitting around 19% alpha, 19 to 23, depending on where it's grown, how it's grown, the growing year, etc. But it's been it's been this way for a while, and we're addressing some creative ways to maybe break down that wall and up alpha yield. So I'm going to talk a little bit about the new aromas, which I talked about earlier in that graph, and some of these are in that graph. So we have some pretty cool stuff going on. In 40 Hill, we have a pina colada with high smelling hop with high pinene. We also have this tropical candy mango hop. This is the it has this 32% other oil. It is a 15 alpha, and it's 3.7 total oil. So I mean that's an exciting hop. I mean, to me, there's this fruit snacks berry, but then it has like some earthiness, apple. It's pretty low alpha, actually 8% beta, which is an interesting alpha beta ratio. You don't see that all too commonly with alpha being lower than beta. It's pretty high, a little 35% other. This one's actually my favorite, 17701. Sour citrus fruit candy pineapple. The descriptors are you can come smell them and you can tell me what they smell like, but 62% other is very high and to me exciting. And then we have these, so you can see that they've been around in the breeding program a little bit longer, but still come up and earned their place. It's lemon peach, but with some floral and some earthy pine and rose, high geraniol. This one has this kind of interesting descriptor watermelon that we've heard several times, which I have never heard of in hops before, but it's kind of exciting. Has high beta, and then we have this one in 5 acre, which is high farnesene, high linalool, and has kind of fruity strawberry, interesting aroma going on. I'm excited to see what the feedback is on these hops as they grow up. But with your guys' input and feedback, and contacting your Hopsteiner sales rep to get a sample of this and rub it, or maybe get a sample of it and do a nano brew with it or a micro brew with it. Hopefully we can get a few of these to advance to 5 acre this year, because they're all mature and ready to get to you guys. Oh yeah. And so, we consider some of them kind of, like unicorns, because they're unique hop profiles. So that's kind of my exciting, let's get pumped about what's coming up in the breeding program talk. I think I'm going to turn it back over to Doug. Now that he's on the call.
Yeah, I apologize for the technical difficulties, but no, it's great, Nick. Again, I just wanted to, particularly in that last slide, we're really trying to, and what we've done with our commercial varieties is, really trying to give you guys, the brewers, the tools to really brew different beers to help you set yourselves apart, from the pack. And I think, this slide shows you kind of what's available right now in the market, with a lot of very different and unique flavor and aroma combinations. And then, like Nikolai was just talking about, we're bringing even more diversity to the hop industry with what we've got going on here. And again, just to point out, and you look at some of these experimental numbers, those first 2 digits are the first year that it was advanced. So, we've got a 2017 advanced, already into the 40 hill stage. So that's skipped, 6 years in the breeding cycle. And, we're at the point now where we need you, the brewer, to tell us what works. And if you're excited about this, as excited about these as we are. So, I think with that, a good segue to Tom to talk about kind of how they look at experimental varieties and work with the breeding program, and he's got some great stuff to talk about. So Tom, I'll let you take it away.
Great, thanks, Doug. Thanks, Nikolai. So I'm Tom Nielsen. I'm based out of Chico, California. Been with Sierra Nevada for 16 plus years now. So basically, I've been working with Hopsteiner team for a long time. Sierra Nevada and Hopsteiner, our history goes back to the beginning of Sierra Nevada, really. I actually think that Steiner is one of our credit references on our when we open new accounts too. So there's a really tight bond there that goes way back. And over the years, just been continually impressed with the technical team at Steiner, and certainly their breeding team, and the amount of resources that Steiner has committed to keeping hops evolving and viable and strong. There's been just countless numbers of collaborations with Dr. Matthews and Nikolai and the rest of the team, and just really impressed with with the new varieties coming out of these programs, which is really probably the most sophisticated breeding program that I know of, using all the latest genetic breeding tools, not non-modified, certainly, methods. Really excited what this expanded gene pool in hops is going to bring to the brewing world here in the next couple of years, and really already has in the last 5 years. So tons of benefits for our brewery, just in creating new beers, good health for the value chain from growers all the way to brewers to consumers. So kudos to Steiner for championing hop research and investing in the future. So next slide, Nikolai, thank you. So talk about a couple of things today. Just briefly review our new varietal evaluation process here at Sierra Nevada. Talk a little bit about Contessa, the new variety, the new name variety from Steiner. And also paint a picture of what I feel, my opinion, of what a perfect hop might look like. So this gets into the concept of designer hops. And as a brewer, you should think about this stuff and really know what you want and know what you're looking for. That can really kind of help guide the process. So, there's probably over a dozen breeding programs all over the world. There's a lot of options out there. You're going to have to screen these new varieties some way, somehow, and certainly Steiner provides a lot of new varieties, experimentals every year to look at. And what we do is start off with hop tea screen. So our hop teas are made with 5% ethanol, 3 grams of hops, 300 mils of the 5% ethanol, and you just agitate that for 10 minutes and separate it off, and you get a team of trained panelists to do a deep sensory analysis. At the same time, we'll take that tea and run some GCMS on it to really zone in on what are the active flavor systems in this hop versus other hops. And you can map out all that data as well. We've got some great chemists and analysts at Sierra Nevada who have really made some great strides in developing our methods and our analysis. So from there, we'll pare it down and bring it into our nano brewery, which is a 10-gallon brewing step, where we'll do kettle hop assessments, as well as dry hop assessments. Typically during fermentation is when we like to dry hop. We get a lot better flavor expression, or preferable flavor extraction. We'll bring those beers into sensory as well as analytical. Again, really try to understand what's happening with the flavors from the hops into the beer, and how they may be transforming. Really measure the hops specifically for their impact and their individual sensory characteristics. So that's kind of phase 2. From there, the ones we really like in advance, if they work for everybody, from grower all the way to the beer, we'll bring into pilot, where we might really look at this new hop in a different new recipe for innovation, or as a possible blend hop for a recipe renovation. So taking an old recipe and seeing how a new hop may work in there. Really try to dial in, say, thresholds of specific varieties, where you can hedge one variety with another variety, just to maybe elongate a position, or just to spread out the general risk in a recipe. Some of our most successful beers have 5-6 hop varieties in them, and we really like that because we can balance the recipe as needed and really not get any flavor deviations over time, which we all know with hops as an agricultural product, you're going to get some year-to-year fluctuation. One year you may prefer this variety over another variety, which can really be difficult if you're locked into one variety. But when you can shift and kind of play a little bit, it's really better for the beer and better for the consumer over time. So that's the very kind of methodical approach that we have at Sierra Nevada. Our R&D team, and innovation teams are plugging away at this all the time, really. On the other end of the spectrum is our experience with 04190 Contessa, which happened kind of very organically. I think we were up at the selection table at Steiner a couple years ago. Pre-selection, we had been discussing as a group, what hop are we going to use in Otravez, a new brand that was coming out, low alcohol, low BU brand. We felt that this beer, although acidified, a little bit sour, Goza style beer, could use some added micro protection. So we were actively pursuing a hop with as high of a beta acid fraction as possible. thinking that that might, create another hurdle to microbial instability in the beer. And we were sitting there, selecting cascades, whatever. And one of our, esteemed Steiner colleagues mentions that this variety, this experimental, which we had played with a little bit before and liked and thought it was very clean and very elegant, has an extremely high beta acid content. And we all immediately look up and look at each other and kind of, just serendipitously, found the hop for the beer, which was really cool. And since then, have really found it to be very successful in lagers. And certainly coming back to the Steiner hop selection room in Yakima every September, there's been some really phenomenal beers that they've showcased. I think the Chuckanut beer was a Helles a couple of years ago. It actually made one of my top 3 beers of that year. So keep going back to the Steiner hop selection room to drink off of that tap. Really, really great beers. So yeah, it was really nice. Part of the pitch, I think, from at the selection table that day was that this variety was going to disappear. This was the last year for it. So I think it gave us even a little bit more impetus to try to save the variety, because we did certainly find a lot of value to it. So 2 different sides of the story: the absolute kind of targeted, methodical approach to just the art and just being connected, with the beer world and the beer family out there. Just you learn a lot from just associating with people out there, and certainly Steiner always brings a lot to the table. So next slide, please, Nikolai.
Yeah, sorry to interrupt here, but I think that's just a great example of the fact that we have varieties that we love and do really well. They grow well, but we have to have that connection with you, the brewer, to really make a commercial variety. And so your example with Contessa, it was a great hop, but it wasn't until Sierra Nevada really stepped up and gave it new life that it was able to become a commercial variety. So when we talk about needing you, the brewer, your expertise in brewing with these very cool new unique hops, it really is a big deal, because Nikolai's got so many great hops, but without you guys, it doesn't matter. So that's why we look forward to working with all of you on these varieties. Sorry, I'll
It's not just me. We got a whole breeding team.
Right. Yeah. No. And same on our side too. I mean, we've got some great people on our side, just learning exponentially about all this stuff and really, really bringing new tools to the table on how to do this really well. So back to the designer hop concept and knowing what you want. Hops, there's a lot of creativity in hops. There's a lot of science in hops. There's a really cool kind of scientific history of hops too. So it's really driven a lot of cool advances, much like brewing science overall. So I want to talk a little bit about that over the next several slides, talk a little bit about sustainability, and then kind of finish off with just a question. And this is not supposed to be a leading question. It's just sort of a throw it out there question. Is a $5 hop a thing of the past? So we'll look at some very, very simple math to take a look at that. And you got 2 of my favorite beers there on that slide too, which I do not take credit for making that slide, by the way. Next one, please. So just kind of running through what a perfect hop looks like to me today. So it should be high yielding. It should have 12 to 14 bales per acre. Over 2,000 pounds, definitely. 24 to 2,800 pounds per acre. You're just creating this incredible value for everybody. So good economics, good financial health of growers, merchants, and brewers. So at that point, you really have a healthy value chain. Number 2, low input requirements. So good agronomics, good stewards of land and nature. Let's limit the environmental impact of our decision making and select some good varieties that don't require a lot of inputs. This can also be very important for health and safety of workers and consumers. And essentially what this does is creates a super premium quality product that everybody can feel good about consuming. And I think, you know, some real fundamentals to that is to do the stacked mildew resistance genetic work that Nikolai is doing and really advancing for both powdery and downy mildew, and selecting varieties that have good mite resistance. So, you know, you don't have to do a bunch of kind of combating of pests throughout the growing season. So it should have good pickability, low shatter, high cone to leaf ratio. So you want to grow cones. You don't want to grow a bunch of leaf that's just going to be, you know, put in a compost pile somewhere. You know, so this also talks a lot about the genetics that Steiner has come up with, just having, you know, really thinking about a hop field as sort of a flavor factory. And that acre is really for myself and brewers, you know, of like mind. It's really the flavors that you're infusing into the beer that we're buying, and certainly that's a big differentiator between people who buy and brewers that buy alpha and brewers that buy hops or pounds of hops, let's say. So we want those cones. We want a lot of cones. We want a lot of flavor. You know, ideally we want even maturity. No risk to double bloom. So, you know, this is a phenomenon that happens with weather fluctuations, and not where you get a really weak harvest because your plant was confused during the growing season and matured early, very weakly, and then matured later. This creates a problem, you know, many problems. Reasonable water consumption is another thing to think about. Next slide, please. Ideally, the perfect hop would be a hybrid Aroma alpha hop. So, you know, maybe ideally it would be an early pick for Aroma, peaking at maybe a 10 to 12 alpha, which is still a viable alpha content to say if the variety does not gain popularity, does not gain brewer acceptance widely, any excess Aroma of this line in the market could fall into the alpha market, which really mitigates the risk for the grower, the merchant, for the industry as a whole. Also, if there isn't as much demand that year for this line, you can just let it hang, and maybe it picks up a couple points of alpha. So this is something that happens in a lot of hops. As you let them sit, they will accumulate, you know, 10, 15, 20% more alpha over time, which you can then feed into the alpha market and gain a nice sustainable, you know, produce nice sustainable economics for the industry. But I guess in my expertise, trained more as a flavor chemist, you know, thinking about the oil fractions and a lot of things that Nikolai was talking about, at Sierra Nevada, you know, we've kind of developed a more targeted approach to think about flavor, much like you know, breeders and hop breeders and scientists out there think about mildew resistance and powdery and downy mildew resistance. So stacked, you know, resistances against these things. So you can really use a similar approach for flavor systems. So we know that there's things that work in hops. We know that thiol-rich hops are good. 3-MH, the tropical notes, 4-MMP, the really clean, bright grapefruit notes, and so on. There's many more of these. Linalool, we know linalool is very flavor positive, biotransformation positive, high levels of dranyl esters, citrus aldehydes that hops produce, octanol, citral. So you can kind of ensure that your hop has a lot of these things, and they're at good, impactful levels in the hop. And these are all kind of water soluble fractions. They're not the oils per se. They live in the oils and in the trichomes, but it's really easy to extract. They're stable in the beer over time, and they create a significant amount of punch, you know, brightness and intensity to aroma and flavor. Whereas a lot of the myrcenes and things out there are really, in a way, while somewhat impactful, largely filler for some of the reasons we've discussed previously. Kilning is a really impactful part of the hop production process. We really want a hop that would dry very quickly, or as quickly as possible. So this has to do with the shape of the cone. You don't want it to phalanx in the kiln and just really prevent airflow from going through that kiln. Stewing at high temperatures when you don't get the airflow through the bed of hops can really kill the flavor and the impact of a hop in beer. So we can impact that a little bit with variety and genetics. We really want excellent storageability. This is in everybody's favor. Low hop storage index values of 0.22 or lower. And this really means creating a very robust lupulin membrane. So that the membrane around that trichome has got to be sturdy. It's got to be impermeable or have low permeability to oxygen, which is what's going to kind of oxidize all those precious oils and resins. So again, this is a case for lower myrcene content, because it's really the myrcene as the hop is maturing that increases exponentially and expands that trichome, that gland, and really thins the wall. So it's like a balloon that you're blowing up. As the more you blow up a balloon, the bigger it gets, and the more kind of thin and permeable the membrane gets. The hop should be easy to process. Again, this may be an argument against excessively high oils and resins, where you're just gumming up systems and slowing down production and making really a negative impact on production. Next slide, please. Seedless. So seeds really are of no use to brewers. They can be added weight. There is some information out there correlating seed content to some of the hop creep behavior that we're seeing out there. So that leads to the next point. The hop should, if at all possible, have low dextrinase activity to limit the unpredictability of hop creep during dry hopping, which is something a lot of brewers are struggling with these days and having to learn a lot about. We also see this phenomenon during dry hopping that pH increases 0.3 points or so. I think it's something like 0.15 per pound. Which is not ideal. They can really bump the pH of the beer to the high 4s, low 5s, which is not ideal. And this is really just a function of the nitrogen content in the hop itself, in particular, likely the amino acid arginine. So if there's this may be more of a growing practice component, but if there's a hop out there that won't need as much nitrogen, I think that's again, lower inputs and also better quality. The hop should have a clean, non-lingering bitterness, but at the same time have strong antioxidant properties. So that polyphenol fraction, sample humol fraction of hops has just got a lot of potential, I think, in beer still, as long as it doesn't provide any negative bitterness. So the last 2 points here kind of pivot into another piece. The hop should have reasonable industry access through a royalty system, which I think Steiner has done a great job of championing with varieties like Bravo and other varieties in the last several years. And really, our new varieties should stem from a competitive iterative process that speeds up research, development, and commercialization of new genotypes with preferred phenotypes by the end users, us, the brewers, and the consumers. The beer drinkers and lovers are the ultimate, judge of whether a hop is successful or not. So those are just kind of, a little brainstorming and putting together some thoughts on what a perfect hop looks like, say from a Sierra Nevada perspective in 2020.
Nikolai, your goal now, it's you can breed that hop, right?
Yeah, I'm just gonna copy and paste this right into my breeding goals.
There's certainly a lot more. I think that the previous bullet of hops have a lot of creativity and a lot of science involved. which is really cool and really a ton of potential. So it's going to be really cool to see where say Nikolai's breeding program goes with all these amazing genetic marker tools and the whole speeding up of the process. So next slide, please, Nikolai. Go back one there. If everybody can just squint for 2 seconds, this is a table, and I guess I'm getting into the part of my talk where I'm asking if a $5 hop is a thing of the past. And here you have on the top there a range of costs for a pound of hop from $4.50 all the way to $10 a pound. And on the left there you have just yield per acre. So 800 pounds all the way to 4,000 pounds per acre. And everything kind of in parentheses is a net loss to the producer. So we certainly want to avoid that, but we want to make sure we're in a zone that we're creating a nice sustainable return for everybody involved in hops, and certainly our growers. So you can see there, next slide, Nikolai, please. Zooming in to just the left side of that table, we're zooming in on $4.50 to $5 a pound per pound of whole cone. And what that looks like on different yields. So a bale of hops, which you see on the left there, is 200 pounds. So a 10 bale yield would be at 2,000 pounds per acre. A $5 hop is really not going to produce, certainly a $4.50 hop is not going to, if a grower is yielding 10 bales an acre, that's not a win proposition. That's not creating a healthy hop industry. But if you look at some of these hops that are coming out of the Hopsteiner breeding program with phenomenal yields per acre, north of 3,000 pounds, you're getting into an area that really makes a lot of sense for everybody involved. And I'm not saying $5 is the right number or $6 is the right number. That's not it. This is just kind of an exercise. And I just want to mention that all of this information is public. You just need to do very, very simple math. This was a study conducted in 2015 by hop growers and published on the Hop Growers of America website. So this kind of wraps it up to my first point, where yield really matters for the health of the industry. You get hops that yield 6 bales an acre but have amazing aroma. It's gonna cost brewers a lot to sustain that hop. So it's going to take more land and things like that. So it's really important. Basically, the message here is that yield has a big impact on brewers, merchants, and growers. So it's really in our best interest to highlight this and not champion too many varieties out there that are that basically have old yield genetics. So yeah, that's kind of my 2 cents on breeding and where I think it is and where it should go and what's really important to think about moving forward.
So thanks, Tom.
Yep.
I did also want to mention, I think because I'm here, I get a lot of credit, but I have a breeding team here at Hopsteiner. Our senior research scientist, Paul Matthews, found me working on hops 14 years ago in Iowa, brought me out. Dr. Alex Feiner in Germany did his PhD on the downy mildew research and resistance. Rachel Bussey is like my right-hand woman. She's also like the queen of the males, takes care of those. Dr. Catherine Easterling was the first author on the paper that has to do with hop chromosomes that actually you referenced earlier within that picture of the trichomes. And Ryan Gregory is our new agronomist, and really exciting to have him on the team among many other researchers. So just, I'm representing all of them here today. So I just wanted to make sure they got a shout out.
Yeah. Thank you, Nikolai. And Tom, I really appreciate the insight in terms of the perspective of what a perfect hop consists of, and also insight into your evaluation program. So all that has been very valuable, and appreciate you sharing that with Hopsteiner, and we appreciate the partnership over the years with Sierra Nevada. So at this point, let me go ahead and go through a few of the questions, and we'll go ahead and start off the top here. Nikolai, this may be more in your realm, possibly Tom. What is the significance of the higher lupulin gland outside of oil and resin concentration, which brewers would standardize their additions anyway?
Am I unmuted? So, I guess there's a few ways to think about it. You do get the stats, but if you think about the hop rub, for example, you pick up some hops, you have them in your hand, you rub them, and if there's more lupulin in the cones that fit in your hands, the aroma intensity is going to go up. There's actually a lot of aroma compounds and flavor compounds also in the bracts and bracteoles itself they're growing on. But the significance being that a pound of hops with higher gland density is going to bring more to the table than one with less. It's kind of actually it's just a way to think about hops. That's why I brought it up. As opposed to just a hop is a hop, but like what's inside that hop is actually what matters.
Right.
I don't know if that answers the question, but
yeah,
and it's also the ability to access those cones too. So one of the things, the challenges for a whole cone brewer like Sierra Nevada is actually accessing the lupulin inside that package, that cone. One of the great things about pellets, which there's pros and cons to everything, is that those cones are readily kind of broken and available to directly infuse into your beer at any step, really. So that's the other piece to that too.
Okay. Next question: are you worried about climate change? And if so, are you doing any breeding for the possibility of warmer climates in the world for the future?
So we are definitely looking into, well, I guess talked a little bit more about it in the last webinar, but it's genetics and environment always have an interplay between one another. And so we grow hops in several different places, and, in several different latitudes. And, we are, some of the Neomex stuff brings in drought resistance. We need to look at, how they do in colder regions. We have fields that are actually north of Yakima longitudinally and south as well, and hotter climates. So the answer in short is yes, and we are trying to make sure that we have hops that are one, durable in several different climates, and then two, excel in particular climates as well. If we had to actually move to different varieties with drastic change.
Okay. Doug, here's a question for you. How does Hopsteiner come up with a commercial name for experimental varieties?
Yes, that's always a fun process. As you brewers are aware, I'm sure, when you're trying to name beers, it's becoming harder and harder to find a name that hasn't been used somewhere else. But it's a collaborative process with our team in Hopsteiner to come up with a name that has that's sexy and has an impact, and maybe talks about exactly what that hop is. Contessa is a good example. It's a noble title of nobility for a female a countess, and Contessa being, and hops being, hop cones being female. We thought Contessa really worked as a noble type variety. A lot of legal hoops to jump through. We want to make sure we're not infringing on anybody's trademarks, and that's always the fun part of the process when you get lawyers involved. But yeah, that's kind of the route we go.
Okay. Nikolai, can Steiner speak to how thiol content impacts the flavor profile of the new experimental varieties?
Actually, might be a better question for Tom when it comes to flavor profile. I mean, there's several publications out there that I've read. But I mean, when it comes to flavor, I know what I like, but he's a flavor chemist, so I might pass it off to him.
Well, yeah, I think they're certainly there in high concentrations. This has been published time and time again, and we see certainly varieties like Eureka having high levels of 4-MMP. I think even Apollo has high levels of 4-MMP. But the thiol fraction is a pretty complicated thing. We tend to focus on the 4-MMP, the 3-MH, and maybe one or two others, but there's a lot more going on there, and it's really getting the positive thiols there at high concentrations and limiting the negative thiols, which can also be very impactful, but not always what you're looking for. I think the story with Altus 07270 is that I think a lot of us tried it and immediately were taken aback by the intensity of aroma produced by Altus at traditional hopping rates. And really the trick with something like that hop is to, like was mentioned before, tone it down, use a little bit less. It just goes a long way because the thiols are present there to such extreme levels. They're so aroma active.
Yeah, Tom, I don't know if you worked with Calypso, but I know there was a paper published where the 3-MH precursor is extremely high in that particular.
Yeah, right. That's another thing about a lot of the new Steiner varieties. They have a ton of precursor, thiol precursor, more so than most other hops. And it's, at that point, finding the right yeast strain that can kind of liberate the precursors. That's the concept. That's what works in actually winemaking. It's really the yeast that's going in there and liberating the bound thiols from the grapes, and they do that very effectively. A lot of brewing yeasts don't have the ability to do that at a high level. So to date, really, brewers rely on mostly on the free thiol component to transfer those flavors from the hops into the beer. But it's not going to take much to kind of click for something to click on the yeast side of things or from the hop side of things to start liberating that thiol potential locked in that hop. So maybe it's something we can do on the farm. Maybe it's more of a pick window thing. Certainly we know pick window and harvest maturity has a lot to do with the final kind of extractable thiol content of a hop. So it's all there. It's just, again, it's how you access it.
Right. Another question for you, Tom, is what are the negative aroma compounds that Sierra Nevada is looking to avoid in selecting hops?
Well, when we have whole cone sitting in front of us and we're rubbing and sniffing, certainly there's a whole bunch. Cheesy is number one. Any indication that there was some stewing that happened in the kiln, kind of any sort of kind of musty smells, anything like that. So those are just kind of basic off flavors. But from a varietal standpoint, it can be tricky. It can be tricky because you have things like Altus out there that may just be so potent and so overpowering and maybe negatively perceived initially, but when you make a beer with it and you dilute that down in a batch of beer, nothing but really nice, elegant, bright notes can express. So there is a disconnect there between rubbing the hops and making a judgment on its character and aroma, and then judging the beer made of that hop can be very different things. Particularly if there's if the hop is very biotransformation positive, it can really change remarkably through fermentation.
So does Sierra Nevada test the new experimentals using different hops as part of different yeast strains as part of your evaluation process?
We certainly have, and I think we've shared some of that work and certainly some ideas surrounding that. But You know, there's really interesting work going on all over the industry on the yeast front. So, you know, pairing some of these new yeast concepts that are out there with the right hop can certainly produce highly innovative beers with very interesting hop-driven flavors.
Okay. Doug, what new Hopsteiner flavor varieties are you most excited about, and why?
That's a good question. Kind of like, which kid do you like best? Yeah, and I mean, as far as commercial varieties, you know, certainly we love all of them, but you know, Sultana and Lotus have really found a home in some of the new beer trends. The New England IPAs, just given their big pineapple and fruit forward, and Lotus bringing just a really unique kind of orange creamsicle with some candied grape and berry flavors that really have brought some cool and unique flavors to kind of what some of the new beer styles are. Talking to and Nikolai could probably answer better for some of these experimentals, but having rubbed some of those 17 cross or 17 lines that we mentioned before last year was as babies, there's some really cool and unique stuff coming down the pike there, and so I'm excited to see how those turn out. But maybe Nick can talk about some of his favorite lines on the experimental side.
Yeah, I mean, obviously over the moon about those ones I showed at the end, but I like Lotus a ton. Back in the day, it was just in the multi-hill nursery. We were bringing people over to the 5-acre plots quite a while ago, and every time we'd have a bus full of brewers come to show them that, I would drag a few of them over into the multi-hill, be like, "This is my favorite. Look at it." And it had a little flippy outy cone, and it's kind of weird, but it was always my favorite. And so when it finally started to catch traction, I was pretty stoked about that one. So I'm really excited to see how that one goes as far as experimental. It just smells awesome. It grows awesome. It looks cool because it has the little flared bracts. So, but yeah, and then
funny. Oh, sorry. Go ahead, Nick. Sorry.
Oh, no, I was gonna say, but
I forgot to mention that in my perfect hop. It needs to look really cool with really nice flared little things.
Yeah, I mean, the Sultana is the exact opposite. It's smooth and pointy. I don't know. It matters to me what they look like. I want them to be cool. No, but yeah, and then obviously the ones that are coming out, the 17s, like, I'm really excited to see them this year in 40 Hill and then get them in front of you guys because, yeah, I'm, like I said, over the moon about them, but I don't want to. They're still on the chopping block, to be quite honest, if they don't do very well this year. We had one last year that made it all the way to 40 Hill, and then it got secondary downy. We pulled it out. We didn't even show it to anybody. It smelled like grapes. It was awesome, but we didn't show it to anybody, and it just got put in the germplasm repository. And, so that can still happen. And
Yeah. I think it's worth mentioning that each has its own sort of creative potential, though, just dialing it in, trying to figure out different ways to use them.
Okay. Nikolai, a question for you. Do you have a favored combination of female and male hop for breeding?
Yeah. I mean, that's breeding is, innately a secret, breeding programs in other crops are held in very high secrecy, but I mean I guess maybe I could speak a little bit to being able to select on the male side now. We have aroma males and alpha males, and then we kind of have like some tried and true males. So to be totally honest, there's a few males that are actually my favorite. Like one is from a family that has a number that's not going to mean anything to you, but it brings in stacked resistance. And when crossed into an alpha family, it doesn't seem to drag the alpha. When crossed into an aroma family, the aroma, if it is heritable, will still segregate into the family. So there are, I mean, like I said, I can't be like, I really like this exact cross because that's a little too much, but it is really exciting to be, a lot of our breeding is really male focused right now because we have, you have been able to do that in the past. So I would say that I have a line of aroma males that have the resistances that, let's say you go into Lotus with it, or I really Sultana is one of the most agronomically perfect hops that I've ever seen. It has high tolerance to powdery, and so I think, and it has that high oil. So bringing in some weird males into that line can unlock a lot of potential, just because of how good of a hop it is, almost to like add things to. So if that answers your question without
Yep. Yep, that's good. Very good. All righty. Yeah, just one more thing on that Sultana. I know from the field surveys that we would do, it was amazing to see a first-year planting or baby yard of Sultana, how mature the cones and the vine looked. Just such a healthy variety that it looked like a mature plant even in the first year. So it's been an amazing variety, and by far our best-selling IPA hop, just because of the versatility of it. So, all righty, gentlemen. Well, again, thank you so much for your contribution. It's been a great finale for us for this Hopsteiner Speaker Series, and want to thank you all and all the participants for joining us. And I'll turn it over to Darren for final closing comments.
Yeah, I'd just like to echo Mike's remarks there. Thanks again, Tom, Doug, Mike, and Nikolai. That wraps it up for our webinar series of Hoppy Topics. A link to all past webinar recordings are available on our website under the online customer portal page. If more questions or comments come up, visit our website or reach out to us directly. We're all here to chat and happy to. Once again, my name is Darren. Thanks for joining us, and Hoppy Brewing. Cheers.